Next page. All right, so we're going to take a look, the next one, at example 4, where this says to use perpendicular bisectors to solve problems. All right, now, so we got a couple of things. We've got actually 3 different triangles in this figure. So we know that this is an isosceles triangle, okay, because sides right here, the big one is, okay. We know that these angles are congruent, all right. And I'm going to put a double tick mark because they've already used a single tick mark here, okay. Now, one of the things that we know is that if these angles right here are congruent, okay, and they split this isosceles triangle, then we know that these sides are also going to be congruent. So we know that that is 4, okay? And so whenever I'm working out these, before I even start to look at the question, a lot of times I like to fill in all of the pieces of information that I know. All right, so what we're looking for is we're looking for angle RSQ, okay? So RSQ. Okay, now as an angle bisector, we also know that these are going to be 90 degrees, right? It's a perpendicular bisector. Okay, perpendicular. So when it bisects it, it hits it at 90 degrees. So if we're looking for this angle right here, we know that this one is 31 and this is 90. So we're going to take 180 and I'm going to subtract 90 and subtract 31. So 180 minus 90, 90. 90 minus 31 is 59. Okay, it also asks for PR. Okay, PR is right here. So remember how we said this was 4, and so this side had to be 4. So we know PR has to equal 8. All right, because we add those 2 segments together to get 8. All right, we've got one more example, and this one says to find angle measures in isosceles and equilateral triangles. All right, so one thing right here, notice we have 3 triangles. I'm going to outline this first one here in red. And this is an equilateral. And if it's equilateral, it also means that it's equal angular. So all of those angles are the same. And then this one, okay, we can tell that it is an isosceles because we have these 2 sides the same, which means these are the same as well. All right. The question, so now, it wants us to find PNO. So one thing about an equilateral is that all 3 angles have to add up to 180 degrees. Okay, so in this triangle right here, angle M, angle N, and angle P all have to be the same. So to find that, we can take 180, divide it by 3. That means all of these angles have to be equal to 60 degrees. So if this one's 60 degrees right here, then that means angle PNO has to be 180 minus 60, right? Because these create a line. So now we get 120 degrees. Okay. Next, we're looking for angle NOP. NOP right here. Now, this is 120. Okay, so if the whole triangle equals 180, we know this angle is 120, so I'm going to subtract 120 to get 60 left. These 2 angles right here combined have to equal 60. But because they are congruent, we can take 60 divided by 2, and we know that they are both 30 degrees. Okay, so all of this comes from knowing that the equilateral triangles are 60, a straight line is 180, okay, and then we can piece it together from there. All right, guys, that's it for equilateral and isosceles triangles.